Hey everybody, this is Alex Merced from AlexMercedCoder.dev, and this is the next video in the Intro to Python course, Python 101 2022. And in this video, what I want to talk about is functions. Functions are probably one of the most important things of all of programming. You master functions, life gets a lot easier. Because imagine this. Let's just create a new functions.py. Okay, so let's say I have three sets of numbers. Okay, so the first we'll do is the really long way. So I got a list nums equals a list of tuples 1, 2, 3, 4, and 5, 6. And I would like to add up each pair. Okay, that's what I'd like to do. So the long way would be for me to do this. Okay, I could be like, okay, for uh, a b of in nums print. That's still pretty straightforward. For a b, actually let's go with that. A b in nums print a plus 2, or a plus b. Okay, and see that's going to go through each tuple. Okay, because again it's going to loop over each thing in this list. So this is the first thing, this is the second thing, this is the third thing. So when it goes loops over the first thing, it's going to take that first thing, make that A, and the second thing, and make that B. So it's going to give me like 3, and then you will get, actually that's the wrong file, functions.py, and you see you get 3, 7, 11. That's wonderful, but what if I have 2 of these lists? So like now I have a second list, nums2, and this time the numbers are like 5, 6, 8. Okay, I'd have to write a whole other loop doing the same thing again. Okay, so then I end up with this, like for AB in nums, or nums2, print A plus B. And I'm literally writing the same code again. The only reason I have to write it again is because I'm doing it over a different list. Okay, so I'm repeating myself. I'm repeating the same logic again. This is where functions come to really help you. Okay, what functions are, they're like pre-made. It's like basically code in a box. You're saying, okay, I have this code that I plan on running multiple times. I'd like to put in a little box. So the way we write it is we write the word def, meaning you're defining a function, and then you give the function a name. And we're going to say like loop over tuples. Actually, technically it's Python, so we should be doing like loop over tuples. Okay. And then you put a parentheses, and we'll talk about the parentheses in a second. And the way the parentheses work is that, let's say you want to put input into the function. The function's going to work with something. So you want to say, hey, I want to, this function is going to receive a piece of information that I don't know yet. What I can do is I can specify it here. So what I'll do is I'll create a variable called tup, representing the tuple that, or the, actually we'll say the list, so we'll call it L for list, that I'm going to like loop over, and then I can actually write that logic in here. So I can say for a b in L, print a plus b. Okay, and again, whenever there's a colon there, that's a block. So basically all the block that's indented here belongs to the function, and then all the code that's indented here belongs to the for loop. But see, now I have this function that's defined, and instead of having to write this twice, now I can do this. I can say, what did I call the function again? Loop over tuples. Okay, so we can go loop over tuples, and I specified this argument called L. So that's, I'm going to say, hey, the first time I want L to be nums, so I pass in nums. That's called an argument. Okay, so this is a parameter, and I can pass as many arguments as I have parameters. So since I have one parameter, I can pass in one argument. And that means that when this function runs, num L is going to equal nums. Okay, and then if I want to do the function again, so I can get rid of this and say loop over tuples, and the second time you do nums2. Okay? And see, now I'm getting the same result, but I didn't have to write this whole for loop twice. So imagine for like much more complicated for loops, that's going to be really useful. Okay? And you can specify as many parameters as you want. So I could be like, and give them whatever name you want. L, cheese, blah, and so forth. Okay? So let's say this. I want to print. So then I also want to print cheese. Then I want to print blah. Okay, let's watch what happens. Okay, right now I'm not specifying any more arguments than just the first one. So I'm gonna get an error, okay? Because I'm not giving enough arguments. Okay? So I need to give those extra arguments, so we can say like 1, 2, 3, 4. Okay? And you see, like at each time, it's printing out those other two things. But what if I want to, like right now it's doing it in order. So see, since 1 is the second argument, it's going to go inside the second parameter in the function definition. If I print out, since I'm writing 2 here, and it's the third argument, 1, 2, 3, it's going to go inside the third parameter. Okay? And then you just imagine that, like, hey, that takes the place of anywhere I see blah in this function. It's just going to run that code. But another cool thing you can do with Python functions that you can't necessarily do in JavaScript is you can do named arguments. So since I gave each of these arguments, these parameters a name, I can refer to them by name. So I can be like, okay, say okay over here, cheese. So usually cheese is the second argument, but let's say I want this to be really blah. I can be like blah equals 1 and cheese equals 2. And this time it should do it out of order. Okay, so you see here, I printed out the 2 first because I told it specifically I want 2 to fill in the cheese argument or the cheese parameter. So that's what's referred to as like a named argument. So you can actually like, if you don't give it a name, then it's going to assume the order. So it's going to fill up the first empty parameter. But if I give it a name, then I can fill in any of the parameters that I want to specify. Okay, and this just again just allows me to wrap up code in a nice easy place. So that way you don't have to keep doing the same thing. Now where this gets really useful is when you start using like return values. So for example, let's write a few functions. Def add nums, which is going to take 2 things, and what it does is going to have a return value, which means the function actually gives you something back. So it's going to return a plus b. So if I ever have a function and I say, okay, let's say there's a variable, result equals add nums to 4 or to 2, what I'm saying is that this variable equals the return value of this function. And what does this function equal? What's the return value? A plus b. So it should be giving me back 2 plus 2, because 2 is a, 2 is b. So a plus b, so 2 plus 2 should be 4. So then if I take that variable that we just assigned and print it, result, and see I get 4. Okay, so essentially the function gives you something back. Okay, now watch what happens if I take away the return keyword. Okay, I get none because the function isn't returning anything. I never specify the word return to tell it to give something back. So there was nothing in the variable. So you have to return a value if you want to get something back. Okay, but the cool thing is, like, I can do stuff like this. So let's say def subnums. So we're going to subtract 2 numbers. A, B, return A minus B. You can start composing these. And this makes for like, so now I can say, okay, first thing I want to do is subnums. And I want to subtract 5 and 3. Okay. And I would take the result of that and add it to 5. Okay. So essentially I'm passing 2 arguments to add nums. The first argument is the result of subnums. So first thing I got to do is figure that out. So basically, again, always inside out. We always start from the inside out. So first thing I'm going to do is figure this out. So 5 minus 3 is 2. So really what I'm passing is 2 and 5. 2 plus 5 is 7. So this should return 7. And 7 is what's going to get stored inside a result. And just to prove that, let's print result. And we get 7. Okay, so you can start creating all these little useful tools to do things that you do a lot on. Okay, so if you find yourself writing the same code over and over again, you can oftentimes figure out, okay, what are the things that are always the same? That's your function code. And the things that change, those are your parameters. So then you can define those inputs. So that way all you have to do is plug in the parts that change instead of having to rewrite the parts that don't change. And that's the beauty of like functions. It gives you, lets you set up these like little code templates that you can run on demand. And that's super, super, super powerful. Okay, so that's the end of this video. I'll see you all later. Have a great day and enjoy.